Let's do a couple more chain rule problems. And in this video, there's also going to be factoring. So like I said in the previous video, that was also the hard part for you. We're going to practice it here more. So we're going to differentiate y is equal to x squared times 2x minus 5 cubed. So there are two different parts to this function. They're being multiplied, so you need to use the product rule. So the first function is going to be x squared. This doesn't require the chain rule. The derivative is just 2x. The second function is 2x minus 5 cubed, and this does require the chain rule. So this is u cubed. So that means that s prime is going to be 3u squared times u prime. Again, you don't need to write the u, but I'm really writing it for the emphasis that we're using the chain rule here. So this becomes 3 times 2x minus 5 squared, and the derivative of 2x minus 5 is 2. So I'm going to combine the 3 and the 2 for 6, 2x minus 5 squared. And now I can do my little cross. So I have y prime is equal to f prime s plus fs prime. And I'm going to start plugging in everything in. So f prime was 2x, s is 2x minus 5 cubed, f was x squared, and s prime was 6, 2x minus 5 squared. Now remember that all these things, like in the first term and the second term, they're being multiplied, right? So the x squared is being multiplied to the 6, which is being multiplied to the 2x minus 5 squared. So again, I'm going to color coordinate. I'm going to do my first term in red and my second term in green. And so I'm going to have y prime equals, I'm going to take out the GCF in the front, and then I'm going to have my leftovers here with the plus in the middle. And then it'll be what's left in the red and what's left in the green. Okay, let's take out the GCF. So I always start off with the numbers, like I've mentioned before. So I have a 2 in the red and a 6 in the green, and the common factor from 2 and 6 is 2. That means that in the red it will be gone, and in the green I'll be left with a 3. In the red term I have a single x, and in the green term I have an x squared. So that what's common to both is 1x. So in the red it will be gone, and in the green I'll be left with one of them because I had 2 and I only took out 1. And then in the red I have 2x minus 5 cubed, so I have 3 of them. And in the green I have 2x minus 5 squared, so I have 2 of them. So I can only take out 2 because that's what's common to both. So in the green it'll be completely gone, and in the red I'll be left with a single 2x minus 5 because I had 3 of them and I took out 2 of them. So I can actually clean this up because I have a common term. 2x plus 3x is 5x minus 5. So what I have left is 2x times 2x minus 5 squared times 5x minus 5. Now this is actually pretty good factored. If you wanted to really go all the way, you could see that in this you could take out a 5, so it becomes 5x minus 1. And then you can combine the 5 and the 2. So it would become 10x, 2x minus 5 squared times x minus 1, y prime. Let's do another one. Y is equal to 5x squared ln of 3x minus 1. So again here I have, they're being multiplied and they both have x's, so I need to use the product rule. So my first term is 5x squared. This doesn't require the chain rule, it's just 10x, the derivative. And then the second term is ln of 3x minus 1. So this is the ln of u. So s prime, and we saw this before, is u prime over u. So in the last video, we saw that when we take the derivative of the ln of u, it's 1 over u times the derivative of the inside. So that means that the derivative of 3x minus 1 is 3 over 3x minus 1. So we have again y prime is equal to f prime s, plus fs prime. I always write my formulas over and over. So f prime is 10x S is the ln of 3x minus 1 plus f was f5x squared, and s prime was 3 over 3x minus 1. Now remember, these are being multiplied, and really here there's a 1. So I'm going to do red, and I'm going to do green, and I'm going to see if there's anything I can take out. So from 10x and 5x squared, I can take out a 5. So I'm going to have my leftovers here. I'm going to color coordinate one more time. This is what's left in the red. This is what's left in the green. And in the front is my greatest common factor. So if I take out the 5 from the green, it's gone. And if I take out a 5 from 10, I'm left with 2. Now I have an x in the red and an x squared in the green, so I can take out a single x. So the x here is gone. And in the x squared, I'll be left with a single x. Now, one thing you don't want to do here is you could see, oh, but I see a 3x minus 1. Yes, but in the red term, it's the ln of 3x minus 1. So unless there was an ln of 3x minus 1 in the green, you cannot take it out. So you cannot take out the ln of 3x minus 1, and you cannot take out the 3 over 3x minus 1. So you have to leave it like that. So here I couldn't take out very much. I couldn't factor very much. So what I'm left with is 5x times 2 ln of 3x minus 1 plus 3x over 3x minus 1. And this is as far as you can factor. You cannot do any more with it. Because once you have the ln, unless the other term has the ln, you can't take it out. And please, please don't do this. Okay, you cannot do that, because in the bottom, the minus 1 is married to the 3x. So it's 3x minus 1 is one unit together. So do not cancel the 3x. All right, let's do another one. We have y is equal to x minus 1, 3 minus x to the 5th. So again, the tricky part about the chain rule and derivatives is, what rule am I supposed to use first? So the part that overpowers the outside part, the exterior function, is the 5, the power of 5. So the inside function is the x minus 1 over the 3 minus x. So you have y is equal to u to the 5th. That means that y prime will be 5u to the 4th times u prime. But when I want to find u prime, I need the quotient rule, because there's an x in the top and there's an x in the bottom. So let me erase this for a second. I have t is equal to x minus 1. I have b is equal to 3 minus x. So t prime is 1, and b prime is negative 1. Be careful, that's a very common mistake I see. People will write 1. Make sure to always take the number in front of x. So when I have u prime, t prime b, b minus tb prime all over b squared. All right, let's put in our goodies. Cross, cross. 1 times 3 minus x minus 1 times negative 1 all over 3 minus x squared. All right, so we need to clean up the numerator. There's lots going on there. So I'm going to distribute the 1. So it's going to give me 3 minus x. And here I have a minus and I have a minus 1. So the minus 1 really becomes a positive 1. So I'm going to distribute it to both. So it's become a positive x minus 1 all over 3 minus x squared. The x is canceled, and I have 2 over 3 minus x squared. So that's my u prime. So I go back to my y prime. I have 5. My u is x minus 1 over 3 minus x to the 4th times my u prime, which is 2 over 3 minus x squared. So to combine that a little bit, I can combine the 5 and the 2, which will give me 10. And then remember, when you have a power in a fraction, the power goes to both. So in the top, I have x minus 1 to the fourth, and in the bottom, I have 4 3 minus x. Let me do it in this. So here I have 4 of them in the bottom, and here I have 2 of them. So I have 4 and then 2, so I'm going to have 6 of them. So 3 minus x to the 6. And here's my final answer. So there was no factoring here in this one, but you had to be able to pick out the outside as u to the fifth, and then recognize that the inside function had the quotient rule. All right, let's do one more. So we have our very common derivative question. Find all the values of x for which the tangent line to the graph is horizontal. And in the next part after the chain rule, we're going to start to graph, and you're going to see why that's important, why we want to find where the tangent line is horizontal. So this means that you're looking for x. Given that the tangent line is horizontal, the tangent line means the derivative, f prime of x. I hope we've drilled that by now. And when it's horizontal, it means that the slope is 0. So we need to find the derivative, and we need to set it equal to 0. So I have f of x is equal to 3x plus 1 to the fourth times 2x minus 1 to the fifth. So I have two parts being multiplied. I need to use the product rule. So my first function is 3x plus 1 to the fourth. My second function is 2x minus 1 to the fifth. That means that f prime, and I need to use the chain rule, the general power rule. So I bring down the 4. I do not touch the inside. I subtract 1 from the top, and then I multiply by the derivative of 3x plus 1, which is 3. So I'll combine the 3 and the 4, which will give me 12 times 3x plus 1 to the third. S prime, very similarly, I bring down the 5. I do not touch the inside. I subtract 1 from the top. I multiply by the derivative of 2x minus 1, which is 2. I can combine the 5 and the 2, so 10 times 2x minus 1 to the fourth. I always clean up my f prime and s prime before I plug it into the product rule. So f prime of x is going to equal to f prime s plus fs prime. So f prime is 12 times 3x plus 1 cubed. S is 2x minus 1 to the fifth plus f 3x plus 1 to the fourth times 10 2x minus 1 to the fourth. All right, we're going to have to factor. So let's use some red, green. We're going to take out the GCF in the front. We're going to have our leftovers with a plus because it's a plus in the middle. We have our leftovers of the red. We have the leftovers of the green. So I start off with the numbers. In the red, I have a 12. In the green, I have a 10. The greatest common factor of 12 and 10 is a 2, actually. So from 12, I'll be left with a 6. And from 10, I'll be left with a 5. Okay, then I have, in the red, I have 3x plus 1 cubed. And in the green, I have 3x plus 1 to the fourth. So in the red, I have 3 of them. In the green, I have 4 of them. So what's common to both is 3 of them. That means in the red, they'll be completely gone. And in the green, I'll be left with 1 of them. So that will go with the 5. Because I had 4 and I took out 3. Then I have 2x minus 1 to the fifth and 2x minus 1 to the fourth. So 5 and 4, 4 is common. So 2x minus 1 to the fourth. Which means that in the green, it's gone. And in the red, I have 1 left. Because I had 5 and I took out 4. Now, this part right here I can clean up. So I'm going to distribute the 6, so 12x minus 6. And I'm going to distribute the 5, so 15x plus 5. And then I can combine like terms for 27x minus 1. So my final derivative factored is 2 times 3x plus 1 cubed times 2x minus 1 to the fourth times 27x minus 1. And remember, don't forget what the whole purpose of us doing this was, to set the derivative equal to 0 to find out when the tangent line is horizontal. And this is really when you see that you needed the derivative completely factored. Because to be able to take a polynomial and solve for when it's 0, you need to have it in factored form. Because when you have it in factored form, you set each factor equal to 0. So I have three factors. I have 3x plus 1. I have 2x minus 1. And I have 27x minus 1. The 2 is not a factor. There's no x with it. It's just a coefficient. It's just a 2. If there was an x, it would be a factor, but because there's no x, it's just a coefficient. Now, the fact that it's cubed doesn't affect, it just means that the factor is there 3 times. But the factor is 3x plus 1 equal to 0, 2x minus 1 equal to 0, and 27x minus 1 is equal to 0. This gives me x is equal to negative 1/3, x is equal to 1/2, and x is equal to 1 over 27. And here are the 3 places where the tangent line is horizontal. So there are 3 x values. So we've done this type of problem before. It was just that the derivative was easier to find. Here, the derivative required the product rule, and for f and s, you needed to use the chain rule, and then you had to factor.